Good afternoon. Thank you all for having me. I'm glad on behalf of my whole company to be a part of this. Ductless technology has come a long way since Mitsubishi brought it to the US 35 years ago, and it definitely is part of a revolution. One of the guys that works at Mitsubishi now used to run a blog called Ductless Revolution. It really is something that's changing, and we're glad to be a part of it. We're glad that your towns are taking a part of it, and we're glad to be part of the Mass CEC, the DOER. It's really interesting what's happening here because Massachusetts is continually being one of the most green states in the country, and that's no small feat. So my name is Joseph Wood, and I am the owner of New England Ductless. We are out of Milton, Massachusetts. We definitely believe in the technology. As I said, it's come a long way, and I think people thought of it only for air conditioning years ago, and now you see many, many homes using it as a primary source of heat, and it's really great at doing that. We practice the golden rule. We try to make sure that we treat everyone the way we would want to be treated, so that when you guys hire us or refer us, that it will make you feel good, look good, and so on, because I don't think there's any way for us to win if the people that we're working with don't as well. And we try to do a really great installation for you because air conditioning has HVAC in general, the market. You know, there's not the highest image, and we send all of our guys to the Mitsubishi factory. It's a 2-day training. It's very intensive, and you take apart equipment, put it back together, and make sure that when you hire us in your home that you're getting the best that you can get. I myself am a plumber by trade. I've been a plumber for 17 and change years. I was going and doing ductless installations for a long, long time before I started to have the idea of doing New England Ductless. My wife and I, she kind of egged me on, and she's my co-pilot. She's the brains of the operation, really. And it's been an amazing thing because ductless just continues to grow, and people believe in it more as they see it. And I think 10 years ago someone had it and wasn't quite too sure about how it was going to work, and then they go to a neighbor's house, and next thing you know, it's everybody wants it, and it's a really great technology. Anyone who calls in for an appointment is going to undoubtedly speak to Alex in our office. She is awesome, really, really detail oriented, and quick study. So if there's anything you guys need, she'll be your front line. And then you're going to see Brian Leo, whose last name, if you can say it, you get $1. And then our other guy, Ravi, but they're going to be coming out doing site assessments, designing your systems, and doing the installs. One of the questions, do they really work? Yes, they do. Mitsubishi rates their equipment down to 5 degrees Fahrenheit at full bore, so that means if they say it's going to give you a ton of heat, for instance, which is the unit of measurement, it's going to give you that down to 5 degrees Fahrenheit. There is a tapering off that occurs, and depending on the model you choose, the lowest they will ever perform is at 75% of what they were rated at. I often tell the story that I didn't do this by design, but I have a high efficiency boiler in my home that I don't have enough gas on my street. When the whole neighborhood turns the system on and it's like 5 degrees or under, the pressure just sags and I have no heat. And I'm a plumber, and I go down to my boiler and I'm looking at it and I'm like, why is this thing not working? Well, meanwhile, I figured this out obviously, but what keeps cranking is the ductless units that are keeping my kids warm. And my kids are age 5 and 7 now, but when I put these systems in 5 years ago, it was baby and 2-year-old. So having heat was obviously really important. It's probably been mentioned, but electricity is the only thing that can be renewed. You can't recreate natural gas, and I think actually Alex might have been the person who said it, the gentleman who came up and spoke about air source heat pumps, that natural gas is not so natural in many ways. So it's something we're pretty passionate about. About the pricing, it's a topic that came up in Somerville, and I want to be very, very upfront with everyone. The base pricing is a model in which we submit a proposal for. As it turns out that not every home is a base price type of home. So what I did in the next following slides is I created a few examples of real world installations to tell you about how these jobs went above base price. No matter what happens, I personally guarantee on behalf of our whole company that you will always get a firm price before we do anything. As I said about one person winning or the other, it can't go that way. It's got to be everyone has to be happy about it. So I want to make sure that everyone knows that when we come to your home, if your home has a unique challenge, we're going to list out why that is a challenge and what it's done to the price. So here we go. This is in Weymouth. This is a really nice house. There were actually some photos of this house up earlier. If you look on the right-hand side here, you can actually see a unit going up to the second floor bedroom between those two windows. The way we got there was by crawling underneath that deck. It was a challenging install, not a bad install, but a challenging install. I think I list here that this one here came out to about $1,200 more. We had to do some modification to the electrical panel. We had some extra pipe in there and in some additional time. And this customer also chose to have a 3-zone system with only 2 connected, so in the future, if they want to add that 3rd zone, they can. They upgraded their indoor units to an FH series, which is a little bit of a more sleek design, not a big price change though. And they also chose the Wi-Fi control. Alex has his remote with him, but most of our clients, we recommend get the Wi-Fi because you can just pull up all the zones on your phone and there you go. You never really would think about it, but walking around to 5 rooms and changing the temperature can be a nuisance. So this is in Milton. Really, really nice house. It's a stately brick home, and getting through every single point of the home required you to hammer drill through. We had to get a boom lift like a cherry picker you see Verizon driving around in. Challenging home. We did. It's a showcase installation. The way we kind of came around the roof line here to jog up and then over was, our installers did an awesome job there. This job was considerably above what a base would be. The brick penetrations, we had to sleeve piping up through chimney chases and things like that. We had to upgrade the panel. It was about 300 feet, or was it 200 feet, I'm sorry. The boom truck and so on. So that's an example of a job that went about $7 grand more than what you would see in the base for this system, which I think was a 4-zone. And then around to Melrose, I always put the picture of the cat. You know, we drilled a small hole to pass the pipes, the wire, and the drain, and I'm drilling, and all of a sudden I pull the drill out and look through, and I'm like, what? But unique house. It's old Victorian, and the basement was completely finished. So finding a way to renovate this place, not renovate it, or to not renovate it, I guess is another way to say it, a way to get this place heating and cooling. The guy buys the place. He's got, I think, 3 kids and 1 more on the way. And his wife was like, you have to put air conditioning in here. So this is the goal. And we found a way. You can actually notice in the right-hand photo some of the slim duct, which is like a conduit we run the piping in. But a really clean install. We actually had to build, there's a branch box, which is custom built. It's an enclosure on the exterior that you can't quite see there, but I have some other photos if anyone cares to see. We had to remove a big shrub, upgrade the panel, extra pipe, time. The inspector required indoor switches, which I've already figured out, and luckily no one in the CCL communities will require those, and some upgrades. In closing, we are thrilled to be working with everyone here. The pricing is really, really competitive, and we're ready to help you guys when you're ready. So if there's anything that we can do for you, please give us a call. Thank you.
I should have mentioned this at first, that following all the presentations, we'll have all the installers able to answer questions for you in the audience before you get to go talk to them one-to-one. Next, we'll hear from Larry Lessard, who is the principal at Achieve Renewable.
Thank you. And my theory on why Booja and Bill weren't here for their testimonial was they're so comfortable in their house they didn't want to leave.
Give me a couple inches.
My company is located in Salem, Massachusetts, and we do work geothermal installations from southern New Hampshire down into Rhode Island and essentially Worcester east throughout most of Cape Cod. So Concord, Carlisle, and Lincoln are really in the center of the area that we cover. I'm going to go over a few topics today. A quick discussion of what geothermal heating and cooling is, some pictures showing the components, and I can show those in our brochures back at the table also because the screen's a little bit washed out from the ambient light. I'll talk about the benefits of geothermal systems and then provide a quick savings comparison, not just cost savings for operations, but also carbon reductions. Ground source heat pump installs or geothermal, we use the terms interchangeably, are typically configured through a ducted system. providing both heating and cooling, all the heating and all the cooling for the home, typically from a central location. Radiant flooring is also possible. Bill, had he been here, his system is radiant flooring for heating and a ducted system for cooling. Baseboards heating is possible. Depends on the circumstances of how old the installation is and how efficient the house is. Very few people opt for that because then they don't have the opportunity to cool because you can't cool through a baseboard system. And then something like a steam radiator is really not compatible with the geothermal system. I want to make it clear that no volcano is needed. Despite the shows you see on the Discovery Channel about geothermal in Iceland, or at least back when the Discovery Channel actually talked about science, that's not necessary for a ground source install. Our static deep earth temperature in this area is 53, 54 degrees, and that's a perfect temperature to exchange with for both heating and cooling. So the components. Inside, you have a ground source heat pump, which has the geothermal components in about this bottom 30% and an air handler above. Those 4 units that are configured that way on the slide are called packaged units, meaning the geothermal components and the air handler are in the same box. It's also possible to have an air handler that's remotely located and the geothermal component in the basement or even outside. And those are called split installations, and they look like the devices there on your left. On your right is a boiler replacement heat pump that provides heated and chilled water. And installations are typically of this quality. You need to get your mechanical room up to par for geothermal. So there's some specific colors that the walls have to be, and particular type of flooring, and that's real wood. That's not one of your laminates. A nice marketing photo. Obviously silly that the unit's in such a finished space. Though we have had clients that have been so proud of their systems, they've installed track lighting in their basement so it's easier to show neighbors. But no one's actually done this. Though affluent communities in CCL, so maybe someone will. But this is a Water Furnace 7 series unit. This is the most efficient of the ground source heat pumps. The geothermal components, as I said, are down here. The air handler is above. You might not be able to see this, but I can show you a similar photo at the table. Up to your left and just above the water furnace unit, there's a set of pumps mounted on the wall. Those circulate the fluid through the closed loop system. This particular photo is closed loop install, and I can explain the difference later. Or actually, I will explain it in the next slide. And then the other box, the white one that's up on the wall, is a zoning controller. Because geothermal units are very good at modulating their output, both the air output and the way the compressor provides heat, they can supply multiple zones for heating and cooling. So in the example of a 7 series unit, that can support 6 different thermostats in the house and provide independent heating and cooling to all of them. Now, ground source heat pumps require an exchange with the ground, and there are 4 methods that are popular in the U.S. Bottom left is a pond loop. That's, to my knowledge, never been done in Massachusetts. It's more typical out in the Midwest. We have different ownership of our ponds and specific wetland protection and all of that. So that won't happen during Heat Smart, I don't believe. Above that on the left is a horizontal closed loop where you put in heat exchange tubing in trenches that are typically 5 to perhaps 10 feet deep. And Those are also less common in our area because our soils are rocky and bedrock is shallow, but about 10% of our installs are horizontal closed loop. And at the right location, it's a fine way to do it. It's very popular in the South and the Midwest where the soil conditions are different. It's also possible, if you go to bottom right, to use a groundwater well to supply the exchange to the system. So if you have an existing irrigation well or even potentially a drinking water supply well, that can be configured to work with the geothermal system as well. And sometimes clients will have us put in this groundwater type system if they have another use for the water, perhaps for irrigation or some other purpose. That would be about 20% of our installations. And in the upper right corner is a vertical closed loop where we drill a series of borings and put heat exchange tubing in, as was explained by Leslie. And 70% of our installations are vertical closed loop. The efficiency of heating systems is rated on a scale called the coefficient of performance. And the coefficient of performance, or COP, is a simple ratio. How much energy do you get out of your heating system divided by how much do you put in? So on the left, that represents an electric hot water heater or an electric baseboard. If you put a kilowatt hour of electricity into an electric water heater, you're going to get a kilowatt hour of heating to the water. So you get out what you put in. The COP is 1, or the efficiency is 100%. Conversely, with a fossil fuel system, in this case an older fuel oil system, you always have energy that's going up the flue. You can't capture all of the energy of combustion. So in this case, 25% of the energy is being lost up the flue, so the COP is 0.75. You put in 100%, but you only got 3/4 of it. And so this would be equivalent to a 75% efficient boiler. Geothermal, your fuel cost, if you will, is the electricity to run the geothermal components, but then the heat is largely harvested from the earth. So you have a small wedge that you purchase to operate the equipment, but you get all the rest of the pie as well because you've taken that from the ground. And that's why the efficiency of geothermal systems is so high, with a COP of 4 to 6, so in the 400 to 600% efficient range using this rating system. And it's easy to be more than 100% efficient if you can reach into the earth's pocket and take the heat from there instead of paying for it yourself. There are a lot of advantages of ground source heat pumps. Most of them stem from the very high efficiency of the heating and cooling. The efficiency results in lower operating costs, lower carbon emissions. There are other advantages. You're eliminating fossil fuel use, so you have, and because of that, you'd have no carbon monoxide risk in the home. And we can talk about that in more detail later. I've got a quick project illustration. This is for a 4-ton load, a 48,000 BTU heating load, which would probably be about a 35,000 BTU cooling load. And that would be, if your house is average to leaky, that might be 2,500 to 2,800 square foot house. If your house is newer or it's new construction, that load might be associated with 4,000 or more square feet. So the air source gentleman had mentioned the bidding to the specification that was part of this process. This is an example similar to what was bid to be selected as an installer. The pre-incentive cost would be $47,000 for a home that already has ducting, but we have to install the ground source and install the heat pump. There are times when you need to add ducting, or you might want to break your ducting into multiple zones, but just assuming you can use an existing ducting system, then the federal tax credit would be over $14,000 on that install. The rebates from CMLP or Mass CEC would be between $3,000 and $14,000. Mass CEC's rebates may decrease at some point in the near future. So stay in touch with us on that. And then the alternative energy credits from the DOER program that Leslie mentioned for an approximate 2,800 square foot house would be about $7,500. The resulting cost would be between $11,000 and $22,000, depending on which municipality you're in. So the install cost, post-incentive, is much, much less than the pre-incentive cost. Probably difficult to see this from the back of the room, but these bar graphs represent operating cost of various technologies. On the left, the short bar, of course, is ground source heat pump, which is the most efficient. Fossil fuel are on the right, we have propane and fuel oil as fossil fuel options, and in the middle is natural gas. Ground source having lower operating costs than all of them. And for this example house, the heating and cooling for the year is estimated to be about $1,500 for that 4-ton home. Carbon emissions follow a similar pattern, with ground source being by far the lowest. The top 3 bars are all electrified heating, ground source, and then electric resistance, and then air source. The carbon emissions for all of those will decrease as the carbon intensity of the electricity goes down. And this particular model uses national averages, and we're already cleaner than this in Massachusetts. So the top 3 bars are exaggerated to the right somewhat. And I never have a presentation where I don't put up a page of numbers that people can't see, so I save that for the end. I can show this to you back at the table, but the third column from the right is the total cost to own a fossil fuel system per year. And this is a 30-year total in the fossil fuel system with fuel and system replacements, because fossil fuel systems don't last as long as ground source systems. You've got a $285,000 spend over that 30 years for heating and cooling. The ground source cost is $160,000. This is about approximately $125,000 savings over the 30-year term. And in summary, ground source will provide you comfort, savings, reliability, reduce carbon dioxide emissions, eliminate carbon monoxide risk. They're quiet, they last a long time, so that all that together gives you peace of mind. Thanks for your time, and go Sox.
Thank you, Larry. And lastly, we're going to hear from Ted Fountain from New Day Energy.
How do you advance it?
Just hit return.
Okay, great.
Or delete if you want to go backwards.
Okay, great. How's everybody doing? All right, great. There we go. Okay, well, welcome. Thanks, everybody, for showing up. I sound a little sick because I am. My kids made me sick for a week. I'm recovering, though, so I feel pretty good now. I feel like our particular technology with wood pellets is probably maybe the least known as far as what they are. I think a lot of people assume wood pellets are some sort of, mystical animal that you have to carry through the basement in a bag, and it's harvested, and then, those kind of things. But it's really not like that. So what I wanted to do in our presentation here is to kind of bring up what wood pellets are and what they may or may not be perceived as. So wood pellets. Wood pellets, if you will, are not anything other than wood. There's nothing special to them other than that they're harvested, they're brought into the factory, they're compressed in a die which has holes surrounding it, and as those fibers of lignin are broken up and forced through these small orifices, the lignin melts under high pressure, right? And so the pellet itself is coated with this slick surface from the tree's actual own lignin composition. Trees have like 30% lignin in them. So pellets are not additive bearing fuel. And so this is kind of like a key thing I think everybody really needs to understand, is that wood pellets are a fantastic fuel, renewable. They come from the slash products, and basically that means that, we go out in the woods and we gather all these trees up, and we use the really nice wood to make furniture. We use the kind of lesser nice wood to make boards for trim work or whatnot, and then the other stuff is just left on the ground to rot and cold combust and produces greenhouse gas emissions. However, you can take that stuff and you can bring it to the mill and you can make pellets out of it. So now you're basically taking what would normally be left on the forest floor to rot as trash and harvesting that for a useful fuel. So what are we going to do with it? What we're going to do is we're going to put it in bags, and we're going to make everybody lug it in, 300 bags a season, and you have to carry it and dump it in your stove like Wyatt used to do. And you're going to have to detail, where you keep them, and you're going to have to make sure that everybody's aware of how to maintain a pellet stove, so you're going to be there every day to deal with that. So we don't really want to do that. We want you guys to experience having awesome wood fuel without having to touch it. Now, we'll let you touch it, but we don't think you need to. So in any case, so what we've done, or what the Austrians did, and this is really a European mindset. So back in the 70s, a gentleman named Herbert Ortner founded a company named Erkofen, and his job was to innovate renewable energy with wood pellets in a way that would be economically effective and also technologically advanced. So he spent decades working on solutions for using wood pellets. He basically created those, if you will, or was on the team that did so back in like Norway in the 70s. So they investigated what you could do. I don't think they tried triangles or anything else. The cylinders really kind of worked out for them. So he built a boiler there in Austria, and the system itself is centralized. So when you think of home heating, we think of like gas, oil, those kind of things. Those systems are centralized. Hydronic heating, everybody's familiar with their baseboard or something like that, or radiant floor heating, which is an option for all of us to do with our home heating, where we can do different types of forced hot water systems. We also do forced hot air, so whatever the distribution method is, we cover that. But his system is developed to make hot water, and it's centralized. So pellet stoves are what we call a district heating solution. So you are heating a room or a series of rooms with one device, where that device is sitting there. So you might not get your kitchen really well, or you might have your kitchen at 64 degrees and your living room might be 85. My wife likes it really warm, so that was effective for her, and the kids like to run out in front of the pellet stove when we had one and dry off after the bath. But the nature of comfort is that you want to have that centralized hydronic thing. So most of us already have a house that may or may not, may have hydronic heating. So now all you're doing is pulling out the one hydrocarbon-bearing fossil fuel boiler that heats that house hydronically and replacing it with one that simply just uses wood pellets. So here's how we store the fuel. These are called flex silos. They are a fabric bag created in Austria. We import them. If you'll notice, the bag on the right is an empty bag, and the bag on the left is a full bag. And essentially what it does is, as the truck pneumatically delivers the fuel into the bag springs on the side will expand, and they'll capture the fuel, and they'll basically store the fuel in a more compacted way. So bags are great, right, because you can stack them, but bins themselves need to be able to have a method to extract the pellets, and in order to do so, you need that V shape. So this does that really cleverly, so that you get a maximum amount of fuel in a small space. And so there you go. This is the truck that would deliver the fuel. So these trucks are created to fluidize the fuel. Those three little bottom sections I just pointed to are basically a arrangement of holes to which a large amount of air is injected, liquefying the fuel, okay? So it basically causes it to fly up in the air and dance and become and behave like a liquid. So they can blow that fuel pneumatically into the bin. So when you think of like I have to grab my bag of fuel, I have to empty it into my bin. This is where we come in and solve that problem. So we're going to deliver the fuel in a bulk means through a hose, through the outside of the house, so that you're not having to touch the fuel or deal with that in any way. And the trucks are pretty shiny too, so they look good when they come up to your driveway. That installation up there was one we did in Berlin, New Hampshire for a community arts center. They have 2 of the big bags. The one on the right is in another house, and they have a bag that's located in the basement. So basically, storage is typically 3 to 5 tons. And if you want to, in your head, think about the equivalency of wood pellets for a standard fuel, you can think of oil as 120 gallons to 1 ton of fuel for pellets. So if you're going to be going through 800 gallons of oil a year, you're going to use, I just did the math, I should do the math in my head, but 120 gallons to 1 ton of fuel. So an average house might use 7 to 8 tons of pellets a year. Wyatt uses a little less because his house is really well insulated. So let's go ahead and figure that you're going to get 1 or 2 deliveries a year. I brought this slide here. It was available. I think when we consider burning anything, we always think that it's going to be a carbon-producing entity here, but pellet fuel is inside the carbon cycle. So your trees that are out here right now are part of what we deal with. And I know a lot of you are going to know more about this than I do, or that you are studied up on it, but I think I just brought this here just to make everybody aware that it's not that we're taking wood or taking things out of the carbon cycle to not put them back in. So, trees that we use for pellet fuel are sustainably harvested, and they must be really to qualify for the fuel that we deliver for the program. So pellet fuel is a low carbon fuel. This slide here I thought was pretty relevant because our competition, if you will, in the market of pellets is to deal with pellet stoves. And I think I brought that up earlier, so it's district and style. But pellet stoves are not very well regulated. They're not a device that's created to be, I would say, efficient in its combustion process. So if you'll notice where modern European pellet fuel boilers come in for particulate emissions per 1,000 BTUs, heating oil per year, they come in quite low. Pellet stoves are like 26 times less or more emitter of particulate emissions. So you think of burning wood in a system. Our system is like 0.02 pounds per million BTUs produced. So they're very, very low particulate emissions. So you don't notice what you would notice if you were burning wood in a more common sense. And I don't think anybody really uses a fireplace anymore. So if you do, we need to talk, because that's, we got even different technologies for that. So let's talk about pellets and where they come from. Pellets are locally sourced. So you might have Bob at a mill at a forest products service in Maine, and they'll deliver the fuel to some guy named Frank at the mill, and they'll grind up the fuel, and then we'll buy it. So there really is not a lot of outsourcing for, we're not going to Saudi Arabia or some other places, or we're not going to Alberta, Canada to buy fuel to power our homes. We're getting it locally. So it's part of our local economy, and it's part of our local energy need. And so these are important things I think we don't really consider, that we want to keep our energy kind of close to home. So the meat of the whole thing is the boiler. And one thing that I really admired about Erkefen when we met, we went over to Austria, my wife and I, we'd won an award for installation excellence and all that. And they give us a trip to go to Austria, and we met up with Herbert and his wife and got to view the factory. And this was kind of an electrifying event for me, because I'm a furniture maker from a really long time ago. So I love things that are detailed, and I love understanding the why of something. And when I met with them, that really kind of pulled me in to understand the creation of quality technology to do a job. So I think pellet stoves, pellet boilers are maligned in that there's a lot on the market to look at, and yet they all look fancy. They have their nice front look. The colors are good, but do they work? Is the heart of the actual technology going to service the customer for a long time? And so the way they've designed their pellet boiler is simple, It's robust and really works all the time. We never have an issue. So to say we take a boiler, we install it, we put the bag in, and then we like to have coffee. So if we're on site, we'll kind of like want that from you. But other than that, that's really all we want of you. In any case, so I've got a larger blow up of this particular slide over at the table, and I can explain kind of the strategy of combustion. But if you look at the bottom there where the flame comes up, that's like a burner arm. And so when you combust the pellets, and this is kind of a key idea here, when you combust the pellets, you're combining oxygen with the fuel, and so you're producing CO gas, and that CO gas is combusting up a little higher as that primary combustive product, and then it goes around the rest of the boiler. And the way that this burner plate allows the boiler to function as similarly to common and ordinary propane or oil-fired systems is that it can reignite very quickly. So when you think of wood fuel, you're thinking of a system that's got to chug along. In fact, I was going to bring this up earlier, but like when I was introduced to wood pellet fuel, my first concept of it was that I would be grabbing a shovel and then I would be like jamming it in some silo pile and then throwing it inside like I would be feeding the belly of a train, as it was steaming away. But this is not what it is. It's just very, very simply built and well made. So what happens is as the fuel travels down this arm with an auger and comes out these holes right here, these are air holes for primary combustion purposes. And you can see the active fire in that particular picture. So when all of a sudden a call for heat goes away and you no longer need any energy from the system, you're not wasting the fuel that's already been gathered. The oxygen's cut off, the fans shut off, everything goes dormant, and the fuel pyrolyzes, turns into just carbon, right? Seems like they were late for something. And turns into carbon, and it just waits, and it'll sit there for up to like 10 hours, barely smoldering until another call for heat comes in. So when you think of switching to wood pellet heat for the benefit which it offers, and yet you're wondering why your system should or should not short cycle, or you're concerned about burning fuel when you're not burning fuel, the Urcafen pellet boiler is super well designed to be able to come on and come off and cycle without disruption and without really wasting any fuel. And that's its design that I really found pretty key. You're looking down at the top of the boiler. This is the guts, and you'll notice that there are these spring-type devices that are hanging inside of the boiler's vessel. And so what's very cool about that is that it automatically cleans every day. So oil boilers, by their nature, some of the systems have pin-type construction, and so you have to have your technician come out and he'll sweep this thing once a year, and he'll determine efficiency based on that particular visit. Well, it's important to note that pellet boilers do make ash, right? And so that ash is going through the system, and as that comes up, it collects on these springs and is shaken off each day. And as it does that, it creates that efficient surface by which you can transfer the heat over. And so they're self-cleaning. You're going to make ash. Ash is part of the product of wood. So when you're going to be having to deal with that, let's make it easy for you. So the entire system compacts all the ash into like a cassette-type device. And when it does so, it'll email you if you want it to, or I can have it text you too, when it's ready to be emptied. That particular bin holds about 2 to 2.5 tons of spent fuel. So you might empty your boiler 2 or 3 times a year. That's it. You pick it up, you carry it over, you dump it on the thing, and then you can dispose of the ash however you'd like. But it's a really simple, convenient method to get rid of the ash. The boiler compacts that all together for us. So, Urcafen, widely recognized as the leader in the industry. They are the ones who innovate. I know that for us, in our US market, they have systems that are kind of their standard run-of-the-mill everything system that they do, but these guys have innovated to the point where they have Stirling engines mounted inside the boiler chambers that produce 1 kilowatt or up to 5 kilowatts of electrical power while the boiler's running. They have condensing pellet boilers. So they really are innovators in the market, and because of that, it's a trusted product. You really know that they're putting their best foot forward for all of that. Here's a typical installation. So you can see standard hydronic distribution. We seem to always replace, on the right-hand side there hanging on the wall, we seem to always replace what was existing for distribution, because 9 times out of 10, the systems that we install, whatever oil or propane boiler that was there is long seen its best day and needs rejuvenation. So we'll replace the whole thing stem to stern. We're a turnkey outfit. We take care of the whole thing. Like I said, all we really need is coffee. And so they're kind of compact. You'll notice that that's a small one. That's heating up like a 2,800 square foot house. We have boilers that range from a 68,000 BTU output to 110 something thousand BTU all the way up to 191. And then those can be cascaded together to close to 750,000 BTUs per hour. So there is a wide variety of heating choice needs that we can fulfill. I kind of just put up here a brief description of what we can do. I know that Concord's different, but with the folks with the Mass CEC rebate, you know, its typical system, maybe 27,000. It depends on how much hydronic work we have to do and a few other things. I'd say in Massachusetts, our lowest might be 23 or something, and our max might be 32,000. It depends on how much heating needs you have. So with the rebate, and then the aches come in, and you know, on a typical system that might use 9 tons, and that's actually kind of a lot. I'd say 5 to 6 might be more common, but let's say 9 tons, you're going to get 34 megawatts, and you're going to get a $684 ache back each year for that. And that's new, so that's pretty cool for us to do that. All right, well. I'd like to thank everybody for being here, and I'm looking forward to anyone who's got questions about the technology. I really, really love this stuff, so questions are the best for me. All right, thank you.